Let's take a look at how I set this up. So the first thing that I did is I created some folders to put all of the components into, and so I have a folder that I call fasteners in my subfolder, and I put the dowel pins and the screws and the nuts into that folder. I created a folder called parts that I put all of the parts into, and then I created a folder called subassemblies, and I made a whole bunch of subassemblies, and let's look at those subassemblies. Okay, so I have a whole bunch of subassemblies. So I did this subassembly where I put the bearings in here. So any components that don't have any relative motion to each other, so these would all be fixed. The bearings would be press fit into this housing, and then they don't move. So I created that as a subassembly. And then I did that for each one of these. So this bearing goes into this gear, and of course created a cone, and I oriented this in such a way that the origin of my subassembly is at this point of the cone right here. And so we'll come back to this assembly here, and for these two, then I made a subassembly with the two sides of this housing. For each one of these cones, again, I created the surface body. I mated these together into a subassembly, and I put it at where the origin is at this point. Now I named these differently, even though two of these are the same. So I did bevel pinion 1 and bevel pinion 2. So even though they're the same, I created two different subassemblies. And so did that for each one of these. So there we see the center point at that one. And then I did the same thing for these planet gears. I put the bearing in there. Now, even though they're all technically the same, I did planet gear 1, 2, 3, 4, 5, and 6 subassemblies, so that later on I thought it made it easier for me to keep track of them. So you see my bevel gears with the dowel pins in them. Again, I did bevel gear 1 and bevel gear 2 subassembly with this drive wheel. Now be careful, there is clearance between these parts, so you can't do this one mated to that face. You have to use an angle plane going through the origin to constrain that location, or do an angle constraint. So for each one of these subassemblies with whatever relative parts don't move, I mated those together. And again, for all of the cones all go to the origin in my subassembly, and so we see the visibility of that origin. Alright, so let's look at then building the assembly, and I'm going to put the parts up here side by side, but let's go ahead and put in the first subassembly. So I will go to place, and I did content center. I need to place my subassembly, and I will select the outer casing, and because of where I put that subassembly, I can do this place grounded at origin, and so there is my outer casing. I'll then do place again, and I'll get the ring mount subassembly. And again, none of these components move, so I can place those grounded at origin. So I have everything so in here that doesn't move, and then I can start placing my parts that do move. I'm going to turn off the visibility of actually I want to turn off the outer casing, so I'll turn off the visibility of the outer casing, and then I want to turn off half the visibility of the inner casing. And so I'm going to set my selection on part priority, and I'll turn off the visibility of these components. Okay, then I will start placing my other components, and I think what I'll do is I'll put these side by side. So here are all of my sub-assemblies. I'm going to view those as large icons so that I can see the parts, and I'm going to then start bringing some parts in. And I think actually I do want to turn the outer casing on for a minute so that I can see that. And so I'm going to bring in the drive wheel, and so I'll bring that in. I'll constrain the z-axis of the drive gear to this hole. And then I'm going to constrain the plane going through the middle of this gear to the plane going through the middle of the assembly. And so I will find the plane going through the middle of the gear, so the XY plane of the gear to the XY plane of the assembly. Now it'll either be mate or it'll be flush. If it doesn't pop up, then I know I need to put it on flush, and now we see that that's in position. And if I drag this, it has 1 degree of freedom rotation. If I go to dynamic simulation, I see though that drive wheel is up here in the grounded group, so I'll right click, tell it to retain degree of freedom, and now it has a revolution joint on this gear. I'll turn off the visibility of the outer housing, and then I will bring in the bevel drive. And so I want this point to always be at the origin of the assembly. So I'm going to turn on the visibility of the assembly origin, and I will do C for constraint, and I'll constrain this point to the origin. And then I'll constrain the axis of this pin to the axis of the bevel drive. And actually that was the wrong one, so I need to do that again. So if I move this out here, so we could just use that hole. So it's going to be, I need to find it, so it's the x-axis. So I need to constrain the x-axis of the bevel drive to that pin. And when I do in dynamic simulation, again, it shows that as a grounded component, the bevel drive. So I'll right click, tell it retain degree of freedom, and it puts a revolution joint onto this one. And if I test it out, so this one rotates. I'll then bring in bevel pinion 1, and I want to constrain this point to the origin. Now there's actually 2 points here. There's the point at the end of this cone, there's also one at the origin. I want to make sure that I always get the ones at the assembly so that I don't end up with some kind of cascading errors. So I'll do constrain, and I'll select this point, and I'll select the center point from the assembly. Okay, and then I will drill down, and I'll find the axis that is going through the center, and it actually it's not going through the center of any of these, so I'll drag this up a little bit, and I'll just do constrain this pin to this axis. And again, under dynamic simulation, I need to retain degree of freedom. So now I have that one with the revolution joint, and I'll put the bevel pinion 2, and so I'll do constrain this axis to this pin, and then I'll constrain this point to the assembly origin, and I will retain the degrees of freedom for that one. And we test it out, so this one rotates. I'm then going to place the ring gear, and so I'll constrain the axis of this ring gear to the axis of the assembly, and then I'll get the XY plane of the assembly to the XY plane of the going through the center of the ring gear, and I'll either do mate or flush. If I do flush, we see that it moves in position, and I'll check my see that I need to retain degree of freedom on that one. I test it out. We have that one now with one revolution. I'm then going to place one of the large bevel gears, so I'll get bevel drive 1, got the wrong one, bevel gear 1. Okay. I'm going to rotate this around, so I'll do on the assembly tab, I'll do a free rotate, and I'll rotate that around. Let's move it down here a little bit, and then I'll constrain the axis of this hole to the Z-axis of the assembly. Make sure that it doesn't flip it over. And let me drag this down, and it may be easier now if I turn off the visibility of this part. I guess I don't really have to at this point just yet, but I want the point at the end of that to be constrained to the assembly origin, so I'll do constrain, and I'll find that point, and I'll constrain that to the center point of the assembly. And so now if I check that in dynamic simulation, I need to retain degree of freedom on this one, and so it has 1 degree of freedom, a revolution. Now I want to put the sun gears on this, and so it may be easiest if I turn off the visibility of some of these other components. So I'll turn off the visibility of this one, and so now I can see these pins where the sun gears go, or where the planets go. So I'll get planet gear 1, and I'm going to insert that onto one of these pins. Now there's clearance between all of these parts. I could insert right up against that edge, but I'm going to allow a little bit of clearance. So there's a total of 6 thousandths clearance. I'm going to put in half of that clearance, so 0.003. So I'll do my constraint, and I'll do insert onto this circle. And because the cones are visible, I'm having a hard time getting that edge, and so I'll temporarily turn off the visibility. So I'll go to the View tab, Object Visibility. I'll turn off the construction surfaces here for a moment, and then I'll do the constrain. I'll do insert, and I'm going to insert onto this circle. I'll insert this circle down here, and I'm going to lift that up off of this part a little bit. So I'll do 0.003 offset to lift that up a little bit, and I'll say OK to that. And if we in our dynamic simulation, if we look at that put a actually it welded the planet gear to the bevel gear. I don't want that welded to that bevel gear, so I'll right click, retain degree of freedom on that. It puts a revolution joint on that, and now this part rotates. We'll do that 2 more times on here. So I'll get planet gear number 2. I'll do constraint, insert onto one of these pins, and I'll do 0.003. Now that offset isn't critical, but it just centers everything up. And now it welded that again, so I'll have to retain degree of freedom on this each time. So I'll get planet gear 3, and I'll constrain that, insert here to here with the offset, and I need to retain degree of freedom. And then we'll do the same thing on the other side. So I'll bring in bevel gear 2. I'm going to rotate that around. So on the assemble tab, I'll go to free rotate, rotate that around. We don't have to have it lined up perfectly. Then I'll constrain this axis to the Z axis of the assembly. Let me move that up, and then I'll constrain this point to the assembly origin. Make sure I retain degree of freedom. Okay, so now we have one revolution joint on this part. I'm going to hide a bunch of these parts so that I can see what I'm doing. So I'll do a crossing window and turn off the visibility of those components. Okay. I could have turned off these as well. Let me get these out of the way. Alright, so then I'll put the suns on here, or the planets. So I'll get planet gear number 4, and I'll constrain, insert, .003 offset. I'll retain the degree of freedom on that, and I'll get number 5. I'll constrain, insert, I didn't put the offset on that one, so let me go back to that and I'll edit that and put in that 0.003 offset. Okay, I need to retain degree of freedom on that one under dynamic simulation. And one more. Constrain, insert. And 0.003. And retain degree of freedom on that one. Okay, so now I have a revolution on each one of these planets, and on all of my gears I have a revolution joint. And then I need to put in the sun gears. So I'll get sun gear number 1. And I'm going to rotate that around. And I'll constrain this axis to the z-axis of the assembly. Now the way I made this, the XY plane, if I go to this sun gear, I have the XY plane below this. I measured the distance, I forget what that is. Let's just check and see what that is. So I'm going to inspect that from here, and I don't know if I'm going to be able to get that from here to here. So I offset that 0.034 for the clearance when I made my subassembly. So I'll constrain the XY plane of this sun gear subassembly to the XY plane of the main assembly. Make sure that that sun gear is in the mobile group, so it now has a revolution joint, and I'll do the same thing on the other side. So I'll bring in sun gear number 2. After I got all of the constraints in, I went through and placed my rotational constraints in the assembly environment, and for most of those it worked, but it would work for the first 2 suns on each side, but then on the 3rd sun it wouldn't work for me. It did work for the bevel gears. If I drag this, this does work in the assembly environment. If I drag 2 of these work, a 3rd one doesn't work. I don't know which one works. It looks like that's the one that doesn't work. Well, now I'm not sure that any of them work. So anyways, line them up by eye, and there is clearance between all these gears, so you should be able to get them lined up pretty good, and I somehow got that one misaligned. Let me undo and see if I can get this. Okay, so there it was back where it was aligned. And then for the bevel gears, so when we're doing a cylindrical rolling cylinder on, or I mean in the assembly environment, when we're doing a motion constraint, if the cylinders are parallel to each other, it automatically does the ratio. But for these bevel gears, this circle isn't parallel to that one, and so I had to put in the ratio. Let me see if I can find one of those. So I'll edit that. And so there are 22 teeth on the smaller bevel pinion, and then 66 teeth on the larger, on this one and the one up here that we don't have visible. And so I just typed in that ratio, and then that worked okay. But again, it didn't work on all of my sun gears, so I got as much as I could constrained, and then went into dynamic simulation. So then in dynamic simulation, I was able to put in all of my rolling cylinder on cylinder and my rolling cone on cones, and everything works then in dynamic simulation. The sun and planets all work, the bevel gears all work, so I was able to get everything to work, putting all of my appropriate joints in dynamic simulation. I turned off some of the components to make it easier to see what is happening, and so I'll go ahead and play this, and we see that this is our input gear. We would have a motor on here normally turning this input gear, which causes this ring gear to turn and the sun and the planets to turn. Now notice that these two indexes aren't lined up, and so we want to line those up. So I'm going to go back to the beginning, and now normally we could have this move at the same time. We put a stepper motor on here, or we might just turn this by hand depending on the machine, and we might, but if we use a stepper motor, we would have some kind of sensors that would sense the location of this and this part, and then to keep those lined up. Or we might want those to turn in opposite directions. We might want to turn some other timing, or maybe we use this as a steering mechanism, so we want one wheel to turn at a different rate than the other wheel to steer around a corner. So a lot of different ways that we could use this, but let's assume that we want these two lined up. So if I drag this one, we can drag that until those pointers are lined up, and then if we play this again, now those two pointers stay in that position. And on some machines you might need to make a little bit of adjustment, so as the machine is running, you have a stepper motor or a hand control to move this a little bit to line up the pointers again if they become out of time. So let's look at how I set this up, and I have it set to run at 60 seconds, and I'm doing 600 calculations, and so I have on the motor, or actually this is on the alignment joint. I have it set to not rotate, so I set it to 0 degrees per second. If I turn this off, it could rotate on its own, so let's turn that off, and I'll play that, and so we see that this is actually rotating on its own now, and I don't want that to rotate on its own, so I'll turn that off. And so I'll go in here to the properties of this one, and I'll tell it 0 degrees per second. Now if I put in an input grapher, I could tell it at a certain time that I do want this one to move, but generally I want this one to be held or not moving. And then for this joint, this would be our input motor. I'm going to set it as 36 degrees per second velocity. So I want to hide the visibility of this part to make it easier to see what's happening inside here. So the same thing is happening down here as up here, except in reverse. And so we'll watch these planets turn the sun gear. So this gear where the motor would be on this one turns this gear, which causes the planets to walk or turn the sun. Alright, so I don't have this one held, so I need to hold this one because I want the planets to turn the sun rather than walk around the sun. So I'll go back. I will hold this one. Okay, so 0 degrees per second. And now I'll play it again. So this one's being held. And this time, as this gear turns, it turns the planets, which turn the sun gears.